So, recently they developed an artificial womb for mice, and I repeat, it's mice, not human beings, and human beings are a lot more complicated in every way, and with the pregnancy and everything, but it can monitor the babies as they develop, and it can do a good chunk of the pregnancy, like over 20%, and they see like unpublished results that they can basically almost do it from day one. They did a lot of things to promote this technology to make it better. One is that they just have it constantly rotating in a very specific pattern so it doesn't stick to the size of the walls of the container, the embryo as it develops. They develop better exchange of oxygen and gases and nutrients. They think with even better exchange, they can do it better. They're working on making it a lot better with that they vary the nutrients over time, like a real pregnancy. It's not always constant in the oxygen and CO2. And there's a lot of fine-tuning and adjustment because they don't really know exactly how it happens in pregnancy in the steps. So they just play around with stuff. But it's a huge leap forward for a couple things. One is if we can start understanding how the body develops really, and then with mice or anything, maybe we don't have to look at this as growing the whole organism, but we can look at it as growing limbs, artificial limbs, if we can understand when we grow them from the most beginning structure, from the baby, or we can look at it over the whole body, how stuff develops. We can look at it growing any organ, not just limbs. We could also try to grow tissue, and this could lead to people regaining lost limbs or making hearts. But not only that, we could look at growing tissue to, as I previously talked about from my videos that I linked, to make artificial milk for babies that's more like real milk, or grow artificial meat better to make us more vegetarian, or a bunch of other things. But we could also use this to make better models of diseases, and by growing more complex structures or seeing what goes on in the womb that hasn't been seen before. And now we can look at it as the womb is. The problem with it is we still probably don't know what's going on in the womb too much. It's not a perfect mimic. But if you have such a bad mimic that the mice don't survive, you don't have a range to play with the variables. So if we can even just get the range narrowed down to what we play with, we can get a better sense in that way. How now? I'm just going for the mice. If we can work away from mice to rats, which are more human-like, rats have a much lower heartbeat, they're much bigger, they have longer births, then we start making our way up. We're a very long way, I would say, from human beings. Very, 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 very long way from human beings. Oh yeah, we can also, this would be a great way to test which drugs hurt mice embryos and stuff like that, so we can know more carefully what hurts pregnant mothers and the fetuses without actually experimenting on humans that are pregnant, which I would argue is a lot more ethical, and we can see what's going on and much quicker. But better than that is, we eventually, I think, could make pregnancy much more manageable. And I don't see this technology working really well anytime soon for the full 9 months, for the full trimesters, 9 months or so. This is really, mice are a lot simpler, grow up a lot faster, a lot more durable. But maybe if there's an emergency in the last month or so, you could have the baby grow up in this chamber, or just for a little bit. And this could save mothers' lives. It could help babies, and more. Now, something I have been thinking a long time to develop such technology better and understand it. Oh yeah, forgot to say is that we can also see what goes wrong if we understand just growth in general and wound healing. There's stuff that happens when it goes incredibly wrong. That can be like scars forming that are really bad. That can be anything from your immune system to going out of control, which is a rapid development. That can be anything from, it can be cancer where you stuff. There's a lot, tumors, a lot of things can happen when something in your body starts developing out of control. And understanding healthy development could lead to understanding this bad development too a lot better. So developing it to help save moms and babies at the last one, I really do think it's doable. But also just the basic science. It is still very far away, but I do think this is something we can do right now to make it better. And this is something I've been thinking about for a while. There's something called microfluidic devices. So microfluidic is micro, M-I-C-R-O, fluidic, F-L-U-I-D-I-C. Micro as in small, fluid as in fluid, and ic, just like making a noun, devices. So these are devices that have little channels they carve in using technology very similar to what they use to make computer chips. Little channels, and they have little pumps, storage reservoirs, everything you think on a big scale for like handling liquids, but on a tiny scale. What if we made one of these devices, and some of them have been implanted in the body before for only experimental reasons, and we implanted into next to the room, and we had it take a little bit of the fluids from either the connection to the uterus, from the baby itself, or from around the room, and we had to carefully sample a little bit at a time and store it, so you can have the sample over days. And then we can pull out the sample and take it out, and then we can use more advanced methods outside the body to reanalyze it to figure out how the chemical composition changes over time. Now, to store this, we can either have tiny little individual chambers with each store a little drop over a set period of time, or we could have it stored in a solid absorbent that starts filling up from one place to another at a different rate. It absorbs first at the surface, then the surface stuff goes more backwards to the back, and then the new surface exposed with the thing. Or you could imagine this device that the surface tension is so high that you screw it into the back and it stays in the back, and then you screw another one and it stays in the next one, and so on as beads, because it gets really high surface tension at small things. Also, within the microfluidic, not only could store the liquid, but in the devices, it could also even monitor it. We have the most famous one is blood oxygen meters, which are non-invasive, but they shine a light and they see how much red and other colors of light your blood absorbs, and then they can tell how much oxygen is in your blood, because the more oxygen, the different color wavelengths. They can also tell your heartbeat, because there's going to be ups and downs in the pulses of how much blood they detect and how bright your blood is. But we can shine light through these samples and detect certain chemicals and how they vary. We can also detect pulses. Then there's ion selective electrodes we can put in these that are very small, and these ones, ion selective electrodes, work by there's a thin ions are things that you find in water with charges, and you can find them in other places too, but they have charges. Now, because they have charges, they can carry electricity. Normal water with no ions is not conductive. Now, how these ion selective electrodes is I put something in between here that only lets certain substances carry electricity, and these certain substances are the only things that can go through this membrane they put in the middle, and water. So then I can detect how much of these substances. This is used to detect every pH, which is how many hydrogen H plus there is. It's used to detect how basic a solution is, and a bunch of other things. So you can develop ion selective electrodes, which are very small and puny. The only thing is that you have to have many if you want to check out many different things. So you might have to make many of these devices in different subsects. But if you could do this in mice, and maybe make a small, safe one for human beings that only take a small sample, it might work to really monitor it, both so we can learn more basic science, or we can have warning when something starts to go wrong. Another way we could do it is Besides ion selective electrodes, we can put temperature sensors, pressure sensors, and it's more like general environmental sensors, these things. I think it might also be useful not only to do in human beings, but in bigger animals like cows and stuff, and it would not really damage the fetus or the animal because it would be such a little sample as taking just continuously taking it. And in the future, it might even be a better port to take a sample so you don't disrupt the whole thing. Also, a reason why that I wanted to take little samples over a daily period is we already know that so much stuff in the human body varies. An example is that your hormones, you have the circadian rhythm, and we've already linked that to your immune system. Your immune system is most active during the day when you're the most busy and exposed to most things. Then it lowers down near the night. Then at the night when you're at most at rest, it then again goes way back up because it can take the energy. And you don't need the energy for other things like running around. There's other things like how much you digest your food varies with the cycle of the sun and moon, how alert you are. There's even some things that different cognitive abilities go up and down with time. And hormones all have a daily cycle. Estrogen, testosterone, all that actually has a daily cycle. So maybe that's all affecting the baby in some way we don't know. It might be linked. So it's also important to have the sample multiple times. And maybe that even leads to better testing because some people think that maybe we should only take certain blood tests during certain times of the day because that might be disrupting it. There's also some evidence that certain medicines are more effective at different times of day than at times of day. There is some effect that painkillers are more effective when it's darker, closer to your bedtime. Some evidence, it's not perfect, it's not a lot, and some things that immune enhancers are more powerful during certain times of day, immunosuppressants, and vice versa, and how much you're secreting. You're also hormones vary over time with, and always your immune system with the seasons. Breast cancer has even been linked to the seasons of the year, and we don't fully know why, but during certain months of the year, during the summer and spring, breast cancer actually gets significantly worse. All of this is largely unknown, and we don't really understand it, but this will be a great way if we has constant monitoring. And I don't want to only say it's going to be used for pregnancy. That's just where I originally got the deal, but it could be used for test subjects for normal people to monitor the blood over long periods of time and see how the blood varies so you can get really accurate data. And then some of this will be sent to lab where we can do fancy measurements like mass spec, which can really analyze thousands of data points. Well, thank you very much for listening. I hope you found this interesting. Please like and subscribe. It really helps the channel out. I'm trying to reach 1,000 subscribers in a year and 4,000 watch hours, which is really, really, really hard. But with your help, I think I can do it. Maybe it takes 2 years, in which case I have to get up the amount of hours. In 1 year, I have to watch 1,000 hours. Also, if you have any ideas for future videos, any comments, anything, please leave them in the comment section below, or feel free to DM me, which doesn't help the channel as much, but it's more personal. However, I don't want to give out my DM, so just DM me if you already have my information. Thank you very much. Goodbye.